Hey, welcome to Programmable Logic Controllers, Module 2, Chapter 6. I'm your instructor, Steve Grotta, and if you've liked the content so far, please hit the like button and the button to subscribe to the channel so we can keep bringing more content. Thank you. Let's get started. Chapter 6. Input. Current versus voltage type of analog inputs. Analog input modules. They're either voltage or current, meaning 0 to 10 volts or 4 to 20 milliamps. Generally, that's the type of modules that they are. This is a chart, again from Automation Direct, that shows a typical wiring schematic for a 2-wire transmitter and a 3-wire transmitter. And as you can see, this is a current output of 4 to 20 milliamp. The device sources 4 to 20 milliamps of current to the input module, which syncs that current. Analog voltage input device example. This is the voltage devices. Again, same exact concept, except the output of it is a DC voltage, usually 0 to 10 volts, 0 to 5 volts, something in that range. And again, the 4 and a 3-wire configuration. Here is a quick description of how a chart would look for the output of the device. You have a voltage on the left and a temperature, let's say. And as the temperature rises, the voltage would rise accordingly along the scale of the output. And you would have some max voltage of, say, 10 volts, whatever the analog card would require. The issue here is that you have to scale your temperatures within the range of the analog signal. Another type of analog output device is a level sensor, and it can be a 0 to 10 volt signal, 4 to 20 milliamp. And as you can see here in this little diagram, you've got a tank with some water in it, and there's a low sensor and a high sensor. And as that float switch would float up as the tank filled up, you would get a level of change to the analog signal. So as the float switch goes up in direction, you would start to see a rise in the analog output, and it would become maxed out when the tank is at whatever level. The issue here is you have to have your float switch scaled in length to equivalent your tank level. Pretty straightforward as far as that goes. Another type of analog sensor is an LVDT, which stands for linear voltage distance transducer. So let's say you had some distance X that you needed to encode with a signal, so you knew where you were. This can be used to record the motion of a table or a cylinder, whatever. So you have some distance that you're going to travel. That distance we'll call X. And attached to that device that's moving, you would have a LVDT, which is some type of a scale with a read head attached to it. Sometimes it's just a cylinder device, but basically as you move the head down the length of the body, you would get a change in your analog output signal. So let's just say that this was some distance of 10 inches, and your 10 inches is going to equal 10 volts when you've traversed the LVDT to its maximum length. So in this particular case, if 10 inches was equal to 10 volts, then 1 volt would equal 1 inch. And obviously 10 volts would equal 10 inches. And as you slide your motion moves up and down, it would add to or take away from the analog output signal according to the position of the read head. And in your PLC, you can monitor this and make logical decisions based on where your location is. So you would basically have a distance voltage relationship. An analog input card must match the type of signal on the device that is attached to the card. If a signal of a device is different, then a converter must be inserted between the card and the device. Chapter 6 is complete.